Securing Content Distribution Networks. Welcome to this lesson on Securing Content Distribution Networks, CDNs. CDNs play a critical role in optimizing web content delivery, improving website performance, and reducing latency for users across the globe. However, because they handle large amounts of data and serve as an entry point for many web applications, CDNs are often targeted by cyber threats, including DDoS attacks, data breaches, and cache poisoning. In this lesson, we will explore how CDNs work, the security risks they face, and best practices for securing them. Let's get started. A content distribution network, or CDN, is a network of geographically distributed servers that cache and deliver web content closer to users. Instead of a single origin server handling all requests, CDNs store cached copies of content at multiple edge locations, improving speed and reliability. Think of a CDN as a network of warehouses. If a company only had one warehouse in New York, customers in California would experience delays in receiving shipments. But with multiple warehouses across the country, deliveries arrive faster. Similarly, CDNs ensure that users can access web content from the nearest server instead of a distant data center. For example, major streaming platforms like Netflix and YouTube use CDNs to distribute video content efficiently, reducing buffering and improving playback performance. Use SSL TLS encryption to secure data in transit between users and CDN servers. Enable CDN security features like DDoS protection and web application firewalls. Monitor CDN traffic to detect and mitigate suspicious activity. While CDNs improve website speed and availability, they also introduce unique security risks that attackers can exploit. First, distributed denial of service, DDoS attacks. Attackers flood CDN servers with excessive traffic, overwhelming them and disrupting legitimate access. While CDNs can absorb some of the impact, large-scale attacks can still cause service outages. Second, cache poisoning. Hackers inject malicious content into cached resources, tricking users into downloading altered files or visiting compromised web pages. Content scraping. Cybercriminals abuse CDNs to steal copyrighted content, trade secrets, or sensitive business information by scraping cached web pages. For example, an attacker might inject malicious JavaScript into a CDN cached website, causing users to unknowingly download malware when they visit the page. Use rate limiting to block excessive requests from suspicious sources. Enable cache validation mechanisms to prevent tampering with stored content. Deploy bot mitigation solutions to stop automated content scraping. CDNs handle massive amounts of sensitive data, making them a prime target for cybercriminals. Securing CDN traffic is critical to protecting user information and maintaining website integrity. First, enforce strict HTTPS encryption. SSL TLS ensures that all data passing through the CDN is encrypted, preventing attackers from intercepting sensitive information. Second, implement web application firewalls. A WAF inspects and filters HTTP traffic, blocking malicious requests before they reach the origin server. Third, enable CDN security analytics. Real-time monitoring tools can detect unusual traffic patterns and automatically mitigate potential threats. For example, an e-commerce website securing its CDN with a WAF can block SQL injection and cross-site scripting XSS attacks before they impact customer data. Force HTTPS-only connections to prevent man-in-the-middle attacks. Use web application firewalls, WAFs, to block common web-based threats. Monitor CDN logs and set up alerts for signs of abnormal activity. Because CDNs distribute traffic across multiple servers, they can absorb and mitigate certain cyber attacks. However, large-scale DDoS attacks can still overwhelm their defenses if not properly managed. DDoS attacks work by flooding a CDN with massive amounts of traffic, exhausting resource and making websites unreachable. Attackers often use botnets, networks of infected devices, to generate this malicious traffic. For example, the Mirai botnet launched a record-breaking DDoS attack in 2016, targeting major internet infrastructure providers and causing widespread outages across popular websites. To protect against such threats, organizations should implement rate limiting, anomaly detection, and automated mitigation tools. Enable CDN-based DDoS protection to automatically filter malicious traffic. Use rate limiting and traffic shaping to prevent excessive requests from flooding the network. Deploy behavior-based detection systems to identify and block botnets in real time. Let's look at a real-world example of how CDNs improve security and performance for an online business. A global e-commerce platform faced increasing cyber attacks, including web scraping, credential stuffing, and DDoS attacks. To mitigate these risks, the company implemented a CDN with built-in security features. First, they required all traffic to use HTTPS encryption, preventing data interception by attackers. Second, they enabled bot protection to detect and block automated web scraping attempts that targeted product pricing and customer data. Third, they deployed a WAF to filter malicious requests, stopping SQL injection and XSS attacks before they reached their servers. As a result, the company improved website performance, reduced security threats, and ensured customer data remained protected. Implement HTTPS bot protection and a WAF for layered security. Use CDN access control lists (ACLs) to block traffic from malicious IPs. Monitor CDN analytics for signs of suspicious activity and respond quickly. Now let's summarize what we've learned about CDN security. CDNs improve web performance by caching content closer to users, but introduce new security challenges. Common CDN threats include DDoS attacks, cache poisoning, and content scraping. HTTPS encryption, WAFs, and bot protection are essential for securing CDN traffic. DDoS protection mechanisms, including rate limiting and anomaly detection, help mitigate attacks. Regular security audits and real-time monitoring help detect and respond to emerging CDN threats. By implementing these security best practices, organizations can leverage CDNs for better performance while keeping their web applications and users safe. This concludes our module on securing content distribution networks.